In this video, we are going to talk about sum of first n terms of some special series. First among them is 1 plus 2 plus 3 plus so and so forth plus n. So this is the sum of first n natural numbers. The next is 1 squared plus 2 squared plus 3 squared plus so and so forth plus n squared, which is the sum of squares of the first n natural numbers. Third is 1 cube plus 2 cube plus 3 cube plus so and so forth plus n cube, which is the sum of cubes of the first n natural numbers. Out of these three, let us consider first one, that is 1 plus 2 plus 3 plus so and so forth plus n. This is sum of first n terms of an AP, which is n by 2 into 2a plus n minus 1 into d. For this series, we have a equals 1, common difference d equals also 1. So substituting the values here, we get n by 2 into 2 into 1, that is 2, plus n minus 1 multiplied by 1, that will be n minus 1 only. So that will be n by 2 into 2 minus 1 will be 1, so that is n plus 1. So we write this sum of first n natural numbers as summation k equals 1 plus 2 plus 3 plus so on and so forth, where k goes from 1 to n is n into n plus 1 upon 2. So this will be the sum of first n natural numbers, n into n plus 1 upon 2. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Next, we will find sum of squares of the first n natural numbers, that is number 2, 1 square plus 2 square plus 3 squared plus so and so forth plus n squared. For this, we will consider k cube minus k minus 1 whole cube. This will be k cube minus, expanding k minus 1 whole cube, we write k cube minus 3k square into 1 plus 3k into 1 square, that will be 3k minus 1 cube 1. K cube cancels with this k cube and we get k cube minus k minus 1 whole cube equals 3k square minus 3k plus 1. Now we will put k equals 1, 2, 3, so on and so forth successively. So first, putting k equals 1, we write 1 cube minus 1 minus 1, that is 0 cube, equals 3 into 1 squared minus 3 into 1 plus 1. Next, putting k equals 2, we write 2 cube minus 2 minus 1 is 1 cube equals 3 into 2 squared minus 3 into 2 plus 1. Next, putting k equals 3, we write 3 cube minus 3 minus 1 is 2 cube equals 3 into 3 squared minus 3 into 3 plus 1, so and so forth. The pattern of numbers that we see here shows 1 cube, 2 cube, 3 cube, so and so forth. So it will be n cube. Then we get this 1 minus 1 0, 2 minus 1 1, 3 minus 1 2, etc. So it will be minus n minus 1 cube, that equals this 3 times 1 square, 2 square, 3 square, which means n square. Then this minus 3 into 1, 2, 3, etc. that will be n plus this one. Now if we add both sides of these number of equations that we got, we find that this 1 cube minus this 1 cube is 0. This 2 cube minus this 2 cube is 0, so and so forth. So finally what we get is, on the left hand side, this n cube minus this 0 cube, that equals, it will be this 3 into this 1 square plus this 2 square plus this 3 square, so and so forth. So we write 1 square plus 2 square plus 3 square plus so and so forth plus this n square. After that, we write this minus 3 into this 1 plus 2 plus 3 so on and so forth plus n. So that will be 1 plus 2 plus 3 plus so on and so forth plus n. And finally this 1 is coming n times, so for that we write plus n. Now this works out to be, the left hand side will be n cube equals this 3. For this sum of squares of first n natural numbers, we write summation k square, where k runs from 1 to n. Next this minus 3 into sum of first n natural numbers, that we write summation k, where k runs from 1 to n, plus this n. Now we have got this n cube equals 3 summation k square, where k goes from 1 to n, minus 3 summation k, where k goes from 1 to n, plus n. This we write as n cube equals 3 summation k square, k runs from 1 to n, minus 3. Now this summation we have found out as n into n plus 1 upon 2 plus this n. Now we will find the value of this summation. So we write 3 summation k square, where k runs from 1 to n, equals this n cube plus this 3 n into n plus 1 upon 2 minus this n. That gives us, where k runs from 1 to n, equals this 3 goes to the right side as 1/3 multiplied by, this will be 2n cube plus this 3n squared plus 3n minus this 2n upon 2. That will be 3 2s are 6, 1 6 into 2n cube plus this 3n squared. 3n minus 2n is plus n. So that finally gives us sum of squares of the first n natural numbers, summation k squared, where k runs from 1 to n. Taking n common, we write 2n squared plus 3n plus 1 upon 6. That will be n multiplied by 2n square plus 3n plus 1 can be factorized as n plus 1 into 2n plus 1 upon 6. So this will be the sum of squares of the first n natural numbers, n into n plus 1 into 2n plus 1 upon 6. The third sum to n terms of special series is sum of the cubes of the first n natural numbers, that is 1 cube plus 2 cube plus 3 cube plus so on and so forth plus n cube. To find this sum, we will consider k plus 1 power 4 minus k power 4. This we write as k plus 1 into k plus 1 cube minus k power 4. That will be k plus 1 into expanding k plus 1 whole cube. It will be k cube plus 3k square into 1 plus 3k into 1 square, that will be 1, plus 1 cube, that will be 1 again, minus k power 4. So this will be first k multiplied by this whole bracket gives us k power 4 plus 3k cube plus 3k square plus k plus 1 multiplied by this whole bracket will be k cube plus 3k squared plus 3k plus 1 minus this k power 4 equals, this k power 4 cancels with this k power 4. 3k cube plus k cube will be 4k cube. 3k square plus 3k square will be 6k squared. This k plus this 3k will be plus 4k plus this one, which will be k plus 1 power 4 minus k power 4. Now we will put k equals 1, 2, 3, so on and so forth n successively. For this one, we write 1 plus 1, that is 2 power 4 minus 1 power 4 equals 4 into 1 cube plus 6 into 1 squared plus 4 into 1 plus 1. For k equals 2, we write 2 plus 1, that is 3 power 4 minus 2 power 4 equals 4 into 2 cube plus 6 into 2 squared plus 4 into 2 plus 1. Then for k equals 3, we write 3 plus 1, 4 power 4 minus 3 power 4 equals 4 times 3 cube plus 6 times 3 squared plus 4 into 3 plus 1, so and so forth. For k equals n, it will be n plus 1 power 4 minus n power 4 equals 4 times n cube plus 6n squared plus 4n plus 1. Adding both sides of these equations, 2 power 4 cancels with this 2 power 4, 3 power 4 cancels with this 3 power 4, so and so forth. And finally what we get is this n plus 1 power 4 minus this 1 power 4 equals this 4 times 1 cube plus 2 cube plus 3 cube plus so and so forth n cube, which we write 1 cube plus 2 cube plus 3 cube plus so and so forth plus n cube plus this 6 into this 1 squared plus this 2 squared plus 3 squared plus so and so forth this n squared plus this 4 times this 1 plus this 2 plus this 3 plus so and so forth plus this n and plus this 1, which is coming n times, and for that we write n. So we get n plus 1 power 4 minus 1 power 4 equals this 4 times. For this whole bracket we write summation k cube, where k runs from 1 to n, plus this 6. For this whole bracket we write summation k squared, where k runs from 1 to n, plus this 4 times. For this whole bracket we write summation k, where k runs from 1 to n, and plus this n. Now we will rewrite what we have found so far. We have found n plus 1 power 4 minus 1 power 4 equals 4 summation k cube, where k runs from 1 to n, plus 6 summation k square, where k runs from 1 to n, plus 4 summation k, where k runs from 1 to n, plus n. Now we write this part on left hand side. So we write 4 summation k cube, k runs from 1 to n, equals, we will write this n plus 1 power 4 as n plus 1 multiplied by n plus 1 whole cube, minus this 1 power 4 will be 1. Then we will send this to the left hand side, that will be minus 6, and here we will write the formula for summation k square as k runs from 1 to n, that we have found out as n into n plus 1 into 2n plus 1 upon 6 minus this 4, and we have found formula for this, which is n into n plus 1 upon 2 minus this n. This we write as n plus 1 expanding n plus 1 whole cube, we write n cube plus 3n square into 1 plus 3n into 1 square plus 1 cube, that will be 1, minus this 1 minus this n into n plus 1 into 2n plus 1 minus this 2n into n plus 1 minus n. Now we will take this n plus 1 common from these three terms and write n plus 1 into this n cube plus 3n squared plus 3n plus 1. Next we write this minus n into this 2n plus 1 minus this 2n, and we write this minus n minus 1 as minus n plus 1. Now we will again take this n plus 1 common from these two terms and write n plus 1 into n cube plus 3n squared plus 3n plus 1 minus 2n squared minus n minus this 2n and minus 1 for this n plus 1. This will be n plus 1 into this n cube. 3n squared minus 2n squared will be n squared. This 3n cancels with this minus n and minus 2n. this plus 1 cancels with this minus 1, and what we get is n plus 1 into n cube plus n square. We write n plus 1, taking n square common, it will be n plus 1. So that will be n square into n plus 1 whole square, and this is equal to 4 summation k cube, where k runs from 1 to n. So finally we get summation k cube where k runs from 1 to n equals, this we can write as n into n plus 1 whole square upon this 4. So this will be the sum of cubes of the first n natural numbers, which is n into n plus 1 whole square upon 4. Let us solve the first problem. Find the sum to n terms of the series 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5 plus so on and so forth. In each of these terms in the series, we find that the second number is bigger than the first number by 1. So the nth term an will be n into n plus 1. Some of the first n terms of the series can be expressed as Sn equals summation ak, where k runs from 1 to n. That will be summation k into k plus 1, where k runs from 1 to n. That will be summation k square, k runs from 1 to n, plus summation k runs from 1 to n. For summation k square, we have n into n plus 1 into 2n plus 1 upon 6, plus for summation k we have n into n plus 1 upon 2. This will be Sn. Now we will take n into n plus 1 upon 2 common from these two terms and write Sn equals n into m plus 1 upon 2 into 2n plus 1 upon 6 upon 2, that is 3, plus 1. That will be n into n plus 1 upon 2 into 2n plus 1 plus 3, that is plus 4 upon 3. This will be n into n plus 1 upon 2 into 2 times n plus 2 upon 3. This 2 cancels with this 2 and we get Sn, that is the sum of n terms of the given series, equals n into n plus 1 into n plus 2 upon 3. Next problem is, find the sum to n terms of the series 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on and so forth. In this series, we find that in each term the second number is greater by the first number by 1, and the third number is greater by 1 than the second number. So we write the nth term as an equals n into n plus 1 into n plus 2. That will be n square plus n into n plus 2. That will be n into n square n cube plus n into n squared plus 2 into n square 2n squared plus 2 into n 2n. So nth term will be n equals n cube plus 3n squared plus 2n. The sum of the first n terms of the series can be written as Sn equals summation ak, where k runs from 1 to n, which will be summation k cube, k runs from 1 to n, plus 3 times summation k squared, k runs from 1 to n, plus 2 times summation k runs from 1 to n. This will be Sn. For this summation k cube, we write n into n plus 1 upon 2 whole square, plus 3 times. For summation k square, we write n into n plus 1 into 2n plus 1 upon 6 plus 2 times. For summation k, we write n into n plus 1 upon 2. Now here, this will be 3 ones are, 3 twos are. This 2 cancels with this 2. So now this Sn will be taking this n into n plus 1 common from each term. We write n into n plus 1 multiplied by, in the first term it will be n into n plus 1 upon 4, plus in the second term it will be 2n plus 1 upon 2, plus in the third term it will be just 1. Now taking 2 common from the denominator of each term, we write n into n plus 1 upon 2 into this will be n squared plus n upon 2 plus 2n plus 1 plus 2. This will be n into n plus 1 upon 2 multiplied by n square plus n plus 2 2s are 4n plus 3 2s are 6 upon 2. This will be n into n plus 1 upon 2 2s are 4 into this will be n square plus 5n plus 6. This finally will be Sn equals n into n plus 1. Now this quadratic polynomial can be factorized as n plus 2 into n plus 3 upon this 4. So this will be the sum of first n terms of this given series. We have to find the sum to n terms of the series 3 into 1 square plus 5 into 2 square plus 7 into 3 square plus so on and so forth. Its nth term will be an. From 3, 5, 7, etc. we have 2n plus 1, and from 1 square, 2 square, 3 square, so on and so forth we have n square. This will be 2n cube plus n square. From this sum to n terms Sn will be summation ak, where k runs from 1 to n, which will be summation 2k cube plus k square, where k runs from 1 to n. This will be this 2 times. For summation k3 we write n into n plus 1 upon 2 whole square plus for summation k square we write n into n plus 1 into 2n plus 1 upon 6. We have to find the sum to n terms of the series 3 into 1 square plus 5 into 2 square plus 7 into 3 square plus so on and so forth. Its nth term will be an. From 3, 5, 7, etc. we have 2n plus 1, and from 1 square, 2 square, 3 square, so on and so forth we have n square. This will be 2n cube plus n square. From this sum to n terms Sn will be summation ak, where k runs from 1 to n, which will be summation 2k cube plus k square, where k runs from 1 to n. This will be this 2 times. For summation k3 we write n into n plus 1 upon 2 whole square plus for summation k square we write n into n plus 1 into 2n plus 1 upon 6. n square into n plus 1 whole square. या 2 square मधला एक 2 या 2 शी कॅन्सल होईल upon 2 plus n into n plus 1 2n plus 1 upon 6. n into n plus 1 upon 2 कॉमन काढूया म्हणजे ब्रॅकेट मध्ये राहील n into n plus 1 plus 2n plus 1 upon 3. हे पुढे होईल n into n plus 1 upon 2 into 3n square plus 3n plus 2n plus 1 upon 3. पुढे Sn होईल n into n plus 1 upon 2 into 3n square plus 5n plus 1 upon 3, जे finally होईल n into n plus 1 into 3n square plus 5n plus 1 upon 2 3s are 6. We have to find sum to n terms of the series 1 upon 1 multiplied by 2 plus 1 upon 2 multiplied by 3 plus 1 upon 3 multiplied by 4 plus so on and so forth. Here in each term the second number is exceeded by 1 than the previous number. Therefore the nth term an will be 1 upon n into n plus 1. This in partial fractions can be written as 1 upon n minus 1 upon n plus 1. If you simplify this, you will get this. Now from this nth term, we will find the first term, which will be 1 by 1 minus 1 by 2. Second term will be 1 by 2 minus 1 by 3. Third term will be 1 by 3 minus 1 by 4. So on and so forth. Nth term will be 1 by n minus 1 by n plus 1. Adding all these terms together, we will get a1 plus a2 plus a3 plus so and so forth plus an equals 1 by 1 plus 1 by 2 plus 1 by 3 plus so and so forth plus 1 by n minus half plus 1 by 3 plus 1 by 4 plus so and so forth plus 1 by n plus 1 by n plus 1. After adding them together, this sum to n terms Sn equals this half minus half, this 1/3 minus 1/3, so and so forth, this 1 upon n minus 1 upon n. Finally what we get is this 1, this minus sign, and this term 1 upon n plus 1, which will be n plus 1 minus 1 upon n plus 1, and this finally gives us sum to n terms of this series Sn equals, after cancelling this, n upon n plus 1. If you like this video, please like it, share it, and subscribe to this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.